Hi everyone, welcome to my channel. This is Leo and let's do some more Leetcode problems today. Today's problem is called making a large island. We were given an n by n binary matrix grid and we're allowed to change at most 1 0 to 1 and return the size of the largest island in grid after applying this operation. An island is a four-directionally connected group of ones. So yeah, as usual, 0 stands for water and 1 stands for the land. Okay, so we have a grid here. Let's walk through the example to understand what's going on here. So we have 1 0 and 0 1. A large island, we can change either 0 to 1 at most once. So we get a island of area 3. Okay, so that's the output 3. And here we have 1 1 1 0. So we have something like this. And at this time we changed this only 0 to 1 and we got a 4, right? And the last one we have all 4 ones. So at this time there's no 0 to change. So we can just return 4. Okay? So how do we do this problem? We first need to understand its complexity. Okay, so let's say we have something like 1 0 0 1 0. Let me write some random code here. All right, yeah, that should be okay, good enough. All right, this is randomly generated. So where is the largest 0 that could maximize the final land? Okay, so if we put this 0 to 1, we're connecting this island with this big island in the middle. Okay, but if we have here change to 1, we're connecting the big island and this little one and this little one. Okay, the same thing happens for this one. So whatever it is, these two will be greater than that one. Okay, so how do we approach this problem? We've done something similar before, where we were asked to find out the area of the biggest island, or count the number of islands, or the number of distinct islands before. So now we can think of something like this. So first, we need to find out all the distinct islands, okay, and mark them as something special. So we don't mark it to 1, we mark it to 2, and for this island we mark it to 3. Okay, and for this one, since we're going left to right, top to down, so this one will be iterated after the 3. And so 4, and there's a distinct island 5 6. Okay, so after this operation we can start to change all the zeros. We change anything to 1 and we do the DFS from this cell again to connect all of its neighboring components. Okay, but there's a problem. So first we need to look through, okay? Look through all ones to mark as distinct IDs, okay? Number 2, after we've done that, we have to look through all zeros to calculate the max area, okay? So before that, we need to do something else. We need to save the area of each distinct island to a map. So in the map, we can use ID as the key and area as the value. Okay, now we can look through all zeros to calculate the max area, and we can update it along the way. And once we're done, we can return the maximum area. Okay, so that's basically how it works. So we're using a DFS to loop through all the neighbors. Okay, let's try to code it out. So the first step is to do some sanity check. If grid is nothing, grid is 0, grid 0, dot length is 0, we'll simply return 0, okay? Next, we will loop through everything, okay? So we will have grid dot length. We will have the dimension of the grid, and next we will have a map. Integer should be ID to area. And we also will have a max area set up for the final result. And we need to have an ID, okay? So starting from 2. Loop through all of the mark distinct IDs and increment ID after each island is found, okay? And we have the ID. Anything else? Yeah, that should be good for now. So now we loop through all the grids, all the cells in the grid. If grid ij equals to 1, we will color it to ID, okay? So, and also we need to collect its area at the same time, okay? So area would be, let's do the DFS, ij in grid, and the ID, okay? We need to have the ID for the iteration because we're coloring it. So basically this is like the flat fill question. Once we got the area, we can save it to our map with the current ID and its corresponding area. And now we can update the max area. With area, okay? Why do we have to do this? Because there's a possibility. All once, like the third example here, okay? So if we got all once, the DFS will give us a maximum number, like n by n, for the area. If we don't update our maximum area here, if we just return maximum area at the end, we may not update max area. So it will return 0, which will give us a wrong answer, okay? So after this, we can increment the ID for next iteration, okay? All right, so that looks good. Now let's loop through the zeros. Okay, now if grid ij equals to 0, what do? First, we will flip it to 1 at this time, okay? So we can say its area equals to 1. And next, yeah, here comes the tricky part. Loop through all zeros to calculate the max area. But how do we calculate the area? We have to first change 0 to 1, making current area equals to 1. Then we will traverse its neighbors to see which which neighbor. Yeah, to see which neighbor is neighboring it and the area to add to area, current area, okay? But here's a problem. Let's see if we have this one. If it goes left, this is 3, which will add 1, 2, 3, 4, 5, 6 to the left side. And if it goes up, it's also 3, so it will add another 6 to the current area. And if it goes right, it will also add 6 to this area, but it is not. So we have to deduplicate. To deduplicate, we need to use a hash set. Use a set to dedupe. And once we know all of its neighbors, so for this cell, its neighbor is 3 and 5, we can just get the corresponding area from the map and add it to the current area, okay? So we need to have a set here. That is neighbor ID, okay? New hash set, maybe new neighbor IDs. And after that, we can add all of those to our area. So now we have all the neighbor IDs. So for integer x or q, anyways, neighbor IDs, we add, well, we get them from the map. We get the area from the map, okay? Dot get q. Okay. Neighbor IDs. So, oh, wait. How do we get the neighbor IDs? We didn't have anything in the neighbor IDs. Okay. So we have to add things to the add neighbors to the set. Okay. So for int direction, okay, we can just use -1, 0, 0, -1, 1, 0, and 0, 1. Okay. So for all of its neighbors, if neighbor x is current x coordinate with direction 0 plus, and neighbor y equals to j plus direction 1. Okay. If neighbor x is inbound and neighbor y is also inbound, and most importantly, if it's not 0, okay? Neighbor y is not 0. At this time, we can add it to our neighbor IDs, okay? So neighbor IDs will add grid neighbor x, neighbor y, okay? And after we collected them into our set, we can query it, query the map for q neighbor IDs. We can add the area to our existing area, okay? Get q. Okay. And yeah, after each time we update area, we should also update max area. Okay. And I think that should give us the right answer. Okay, next we have another thing to take care of, which is the DFS, but this should be pretty easy. In this order, yes. Okay, so if it's in bound and j is larger than or equal to 0 and j is less than n, and let's say grid ID equals to 1, because we were looping through all ones and try to mark it to ID, then loop through all of its neighbors and calculate the area and to return the area. Okay, so we should first color it grid ij equals to ID, and we should have a area equals to 1 because we're standing at this cell. Okay, let's say this cell. Okay, we're standing here, so we change it to 1. And next we want to do all of its neighbors. Okay, so for int the same thing, let's copy it from here for all the directions. Still neighbor x would be I plus direction 0, neighbor y would be j plus direction 1, and this time area will add DFS, all of the neighbor x's, all of the neighbor y's, and grid and ID. Okay, and after this, so after this was called, we will return area. Okay, else if it's outside of the out of bound, we'll simply return 0 as the area of that cell. Okay, so this should give us the right answer. Okay, yeah, I think it passes. And the last thing is to analyze the complexities. So since we're looping through all the elements here, so I guess the time complexity is n squared. And the space complexity, we have a map, right? And we have call stack, but it's fine for DFS. And anything else? No, I don't see. We have a set, right? So worst case, we are saving all the nodes in here. Okay, so the space capacity is also n squared. Let's submit it. Okay, it passed. All right, thank you so much for watching. I hope this video is informative to you and will help you with your Leetcode journey. I'll see you in our next video.